Tom here from Lawrence Systems, and we're going to talk about pfSense getting started, kind of a start to finish video for setting up your pfSense firewall, building it custom or virtualizing or buying the hardware. No matter which way you want to do it, we'll talk about all the methods in the beginning, then we'll walk into some of the hardware, and then we'll go through the loading process, getting it configured, building your network. So kind of a from loaded to multiple networks, VLANs, etc. It's going to be kind of in depth here, but I want to go through all the features and options with pfSense and cover them so you can kind of have it all in one place. But before we get started, let's first, if you'd like to learn more about me or my company, head over to lawrencesystems.com. If you'd like to hire for a project, there's a Hires button right at the top. If you'd like to help keep this channel sponsor-free, and thank you to everyone who already has, there is a Join button here for YouTube and a Patreon page. Your support is greatly appreciated. If you're looking for deals or discounts on products and services we offer on this channel, check out the affiliate links down below. They're in the description of all of our videos, including a link to our shirt store. We have a wide variety of shirts that we sell, and new designs come out, well, randomly, so check back frequently. And finally, our forums. Forums.lawrencesystems.com is where you can have a more in-depth discussion about this video and other tech topics you've seen on this channel. Now, back to our content. And I want to start here with a little bit of history. So pfSense is a fully open source firewall. And for those of you that have been doing this for a long time, and especially people like myself who've been an advocate of open source firewalls since, well, the early 2000s, late 99, I think is when I first started messing with open source firewalls, and I was told I was crazy. Now they're pretty much very, very common. Now pfSense is used in corporate environments. I have a separate video talking about that. There'll be someone below, I'm positive, that puts their caps lock on and tells me it's not ready for corporate, it's not really used in corporate. You're wrong, Tom, but I can tell you because of the amount of consulting we do, the page on NetGate and some videos I've done deep diving where I show companies, large companies, including MasterCard, hiring for pfSense professionals. I can tell you it's well used in the corporate, even the banking markets. So I'm not here to debate that. The person with the caps lock, hi. Anyways, I'm not gonna feed the trolls today. I just want to at least mention, yes, it's used in corporate environments, and yes, it can be used in your home environment. So pfSense is a fork of the Monowall project. So in 2014, a competing open source firewall project, OpenSense, was forked from pfSense. The first official release was January 2015. So yes, I am aware OpenSense exists. That comment comes up almost every video I do on pfSense is please do on OpenSense. OpenSense is a fork with some different opinions than pfSense. I stay with pfSense because it is well supported, well documented, and I trust it very well. Now, important concept in any firewall is trust, because this is the divider between you and the internet and all the devices you may have in your network. So you have to have something solid and secure, and just because something has more features doesn't necessarily mean it's something I need. I find the features to be quite adequate in pfSense. So that's as much I'll talk about on that topic, but I'll leave a link to this here. Now a little bit more context. Open source security, this is pfsense.org, where you're going to download pfSense from. And it is fully open source. This question comes up a lot as well. People say, well, is it really open source or partly open source? No, it's fully open source. So I'm not sure where people get that misinformation. I usually just link them to the GitHub or anywhere. You can download all the source code. You can compile this all yourself if you so feel the need to. I'm going to tell you it's much easier to go to the download option over here and download pfSense. It's already compiled for you. Now, what does it run on? That's an important aspect. pfSense does not run on all ARM devices. It does run on the NetGate provided ARM devices. So no, your Raspberry Pi won't run pfSense. Sorry, I don't know if there's any plan to ever support something like a Raspberry Pi. But the custom ARM boards that were commissioned by NetGate, the commercial company that provides support for pfSense and makes the hardware, when you buy a NetGate piece of hardware that does have an ARM board in it, they have a custom ARM, still open source, but they compiled it specifically for ARM. Now those downloads, like I said, are not available directly for some other custom ARM boards that you have. And ARM's a lot different than building things on x86 because things have to be custom compiled for that particular ARM board to make it work. So the only ARM proper support that there is right now in August of 2020 is on the NetGate devices that are shipping with custom ARM boards in them. So that hopefully that clears that up. But if you're building x86, we're going to talk real briefly about the hardware before we get into the download part, because, well, if you're going to build it yourself and buy some parts, or maybe you have an old computer laying around and you say, this is what I want to do is build it. I do have, and I'll leave a link to this Super Micro 1U box that I'm not building it because I think it's the best for pfSense. I'm choosing it because I have it laying around, and it seemed like a fun thing to do a demo on. Now this has 4 onboard ports, which is great. That's what you need, is a few onboard ports. But let's say you have some other PC. And in my 2018 video, I just had a motherboard laying around that I don't have. Well, it's not laying around anymore. I got rid of that old one, and I'm going to use this Intel card in this, but this is the same Intel card I had recommended before. And let me jump over here and show you. You can find this Intel card, and I'll leave a link to this. It's the 08092P Intel card that I found off of eBay. I think I paid around $35 or $40 for it, which is still what they're going for. They're relatively inexpensive. Some people think they're worth more than they are. But you can find these relatively cheap, and they work really, really well with pfSense. These are 4-port Intel cards. That gives you 4 spots you can plug into, that if you have just a standard computer, maybe an older one, because pfSense does not require a whole lot of processing power to run. Even doing gigabit networking does not require really high-end CPUs. You can plug these in and away you go, and you have 4 ports on that PC. Now, buying the Netgate devices, they have a whole list of them on there, and they have all the specs listed on their site. And as I said, when you buy a Netgate device, one, you're going to get guaranteed to work pfSense. No troubleshooting of, hey, I got this weird, quirky problem that I ran into. This is the same thing with when you virtualize it. You have these weird, quirky problems you run into. Virtualizing is my least favorite way to do pfSense, but there are guides on how to do it. I have a guide on even how to set it up inside of XCP-ng. There's plenty of documentation on that. It's really popular to do, but be warned, it is also the most picky way to do it, because you run into weird performance issues. That's because you're now creating a virtualization layer and then virtualizing a network interface. So there's a lot of potentially more problems with it. Someone will have their caps lock on saying they've run it with no problems for some amount of time. Yes, if your hardware lines up and everything aligns perfectly, you'll have no problems. If it doesn't, you'll spend a lot of time in forums going, why does it do this weird thing? Why does it only get really slow performance randomly, etc.? But for commercial installs, I do highly recommend buying the Netgate hardware. And if you're looking for not playing with hardware at all and you're a home user, I'm holding in my hand an SG1100. The SG1100, great box, works really, really well, and does an excellent job of up to 500 or 600 megs per second. So it's not going to, if you have gigabit internet at home, this is going to be a little bit underpowered for you. It's not going to get full gigabit, but for a, right now they're about $199 or $189, just under $200. You can get a complete, well-supported, and I have done videos that this will even run full HA proxy on here with, let's encrypt, search, and reverse. So you can actually get quite a bit done with a tiny little box like this right here. Anyways, on to the build process, because you can spend more time at the Netgate site figuring out which one fits for your commercial project. They have all the speeds and everything listed on there. So onto the commercial side here, or non-commercial side of, I have a computer and we're just going to build it. Let's start here. And let's start with downloading and loading it now. So now we can get to that part. And we want to download, we'll go here, architecture, 6 AMD 64-bit, which means it works on Intel, works on AMD, works on 64-bit processors. Are you going to load it to a USB mem stick or a CD ISO? Those are your 2 options that you have on there. So, and pick your download location. Now, for demonstration purposes, not for anything more than this video, let me refresh the page real quick. I'm going to now walk through what the loading process looks like. It's actually really straightforward. So this is not installing it on this machine next to me, but this is just to show you what the installer looks like and go through the options. And there's very few of them, so this part's pretty quick. I will mention, I've done a video on this before, recover config.xml. If you somehow goof up, completely break your pfSense install through some level of corruption or not following documentation properly, there is a way to recover it. And I thought this is a great feature that they have built in. All the configs are all in one XML file located on here. And I've got a separate video just on recovering pfSense. But what you do is you can load the pfSense CD and recover the XML file, grab that file, and reload all the settings back in there. So there is also a rescue shell option. So if you are trying to fix a broken install, great. I've had to use this on people who forgot to back up that XML file, because you have a really easy way to back this up. And A lot of people don't, so that gets used more frequently than probably it should. But if you have backups, you can just reload, provide that XML file when you're doing the install, and done. You're back to your pfSense setup and configured. Key map. For me, I'm American. It defaults to American. It configures the American setup, so I'm good on the keyboard layout. No problem. Guided disk setup, auto UFS, that's fine. I have a separate video on custom pfSense with ZFS where I talk about using ZFS if you have multiple drives. Generally speaking, auto UFS is fine, auto ZFS is fine. We're going to go ahead, we have a single drive in here, just do the auto UFS. I haven't had a problem with it. And now it's installing. That's pretty much going to be it here. Goes through, installs the base, overall progress here. And depending on the speed of your machine is how fast this is going to install. This is all in real time on my Zen server. And just about done. Do you want to make any more modifications? Nope. Reboot. That's it. It's going to reboot and have pfSense up and running. That's as easy as the install goes. That part is so straightforward with pfSense. Now, I will show you what it looks like when you boot up to the first time menu, if you need to look at it. So here's the first time boot menu, and we'll just fast forward while it runs through all the boot process setup. And this is what the boot menu looks like once it's started up. Now, the other device sitting next to me, this only had a VGA out. That's why I didn't try to do it here. I'm showing it through the virtual one. But when we do all the rest of the demo, we're going to be doing it on this actual hardware right here, not this. Now, the one thing you may have to figure out, and you'll see is going to be different about this because this has so many network interfaces on it with this little 1U Super Micro, is assigning interfaces. I only added 2 network interfaces virtually to this, so they're pretty easy to find, and they're both plugged in and running. But when we are trying to figure things out, which one's which, it says up and up. If you have a list of them, it'll tell you which ones are up and which ones are down. As a matter of fact, let's go ahead and take one down. Well, that actually appears to have removed it, not taking it down. But instead of up, you get a down anytime there's a cable disconnected. So if you are trying to sort this out and figure out which interface is which, that's how that'll go, is you have to kind of go through and plug each one in, figure out which ones are up, and then you can assign the interfaces. Now, if you buy one of the Netgate devices, it's kind of small here, but they're all labeled opt, LAN, WAN. So all the Netgate devices come labeled out of the box with all of them, especially the ones with multiple interfaces. They'll have the interfaces listed on there so you can figure out, which one's which without having to go through the menus at the console level. So now we're going to boot this up and start with the getting started part for logging in for the first time and go through that. So I'm going to plug this in and jump over to that. Okay, this system's booted up, running pfSense, and ready to be configured. So everything's at default. And I didn't have to do too much guessing because I know these Intel cards quite well, that if the card's facing this way, with the little lit part at the top, this is IGB0, IGB1, IGB2, IGB3. So by default, IGB0 is going to be for the WAN, IGB1 is going to be for the LAN. And I have here a edge switch, and I have done a review of this. This is the Edge Switch 10X. You can find it on my channel if you want to know more details about it. I just happen to have it. It was black and matched this, so that's why it's here. It's not like I'm absolutely endorsing this is the best switch to work with pfSense. I have found pfSense to work with amazing variety of switches. I haven't found one it doesn't work with. We've set up Cisco, HP ProCurve, lots of Unify, obviously, and Unify being one of my preferenced ones, but the Edge switch line works fine. So it's fully standards compliant when it comes to things like setting up VLANs, so I haven't had any issues setting that up. But what we're going to do now is start setting up and configuring pfSense once you've decided how you want to do this. Now, a managed switch is not a requirement, but if you want to do VLANs, a managed switch is a requirement to set up VLANs. The other option would be having everything, because we've got, well, plenty of network interfaces on here, having each interface provide its own network. Now, doing a VLAN versus providing its own network. VLANs are very convenient. I've got an entire video about VLANs, but I will mention that VLANs are a shared medium, so if you want to do multiple networks over a VLAN, they do share a physical cable, so there is bandwidth limitation. You cannot get the full amount of 2 networks simultaneously if they're split up with VLANs, so I'm not going to spend too much time on it. I have a VLAN video, a whole explainer on that, but we will be covering that, how to configure a VLAN in this particular video and how to get the networks configured. Now, pfSense by default comes up with 192.168.1.1 to log into it. And it's a self-signed certificate, so we're going to accept the risk and continue. Admin pfSense is the password. That is from a default load. It does not ask you during the install to set up a password. It asks you nothing other than those options you set. So you have to set up the password yourself once you go through the wizard. Now, the interesting thing is it's already routing traffic. And the way you want to configure the WAN side on a pfSense, generally speaking, for most all use cases, is going to be you want the, let's say, Comcast cable or whoever your internet provider is, Comcast, Wide Open West. There's a lot of different providers, or if you're out of the country, there's way more than I'm aware of. You're going to want to have that set up in bridge mode so your WAN gets a public IP address, or in some cases, when we're doing this commercially, the public IP addresses are statically assigned and provided to us from the provider. So that's an important aspect, but I can't really do that here. This is in my lab, so there's going to be an option that we change to allow it to work inside my lab properly. Hostname, pfSense YouTube. Seems like a good name, but you can call it whatever you want. DNS servers, I like 9.9.9. And override DNS. Allow DNS servers to be overridden if it's on DHCP. I do not want that to happen. Now you're setting the primary DNS server for pfSense to use to get out to the internet, or you can just leave it blank and allow override provided it's DHCP. The options are yours. This is still different than when we get further down in this review and tutorial of how you would set up DNS specifically for other things. I have a couple separate videos on that as well, but we will cover that. But I choose 999. Choose the one that makes you happy. Next, I am in Detroit, so we're going to choose America Detroit, but choose a time zone that works for you. So go here. I just like that Detroit's in there. It always made me happy. It automatically has a time server in there to set the time. That's great. Configure WAN interface. Now, normally, if you're a home user and you're just getting an IP address from your provider, DHCP works perfectly fine, especially when it's in bridge mode. You should get a public IP assigned to it. You have the option of PPoE. A lot of people have a lot of questions about PPoE, and I have no answers for you on it. Spend time in the forums if you're setting up PPoE and have problems. The reason I bring that up is because we just don't see that many of them here in the US. We really see very few of them on our clients. It does work with PPoE. I do know there are nuances to it that I'm unaware of and have no way to stand up and test. So if you are having problems with that, I'm really not the person to ask because I don't have a way to demo that. We're going to leave this at DHCP, but if you had a custom MAC address, you could assign that here too. Maybe you have some reason you want to do that. Custom IP addresses, anything can all be put all in through here, your PPoE or PPTP configurations. But we are going to uncheck these boxes, which normally you leave checked. Block RFC 1918 networks means block your private IP addresses. Because this is in my lab, it's going to get a private IP address. Therefore, I want that private IP address not to be blocked and not to cause issues. And people who are setting up pfSense in a lab, this is often the fix that you'll find that fixes, hey, I can't get certain things to work. And I'm like, yeah, you're probably assigning the WAN a private IP address because it's your lab, and voila, you can't do it unless you do this, so just go ahead and change that. All right, LAN IP address. Now, many home networks in that support 192.1 or drop to default at 192.168.1.1. I recommend you change this, and you can change it to any type of private IP address you want. I'm going to put 192.168.55.1 just because, but if you leave it at 192.168.1.1, the challenge you run into is, let's say you're on another network, your friend's network, but you want to VPN back to your pfSense system. Well, if they have a 1.1 network, which is the default for lots of consumer network products, like many of them, you will have a trouble routing back to your house because, or wherever your pfSense is installed, because, well, you have a problem with the routes matching on both sides, so it doesn't know, are you trying to go to a local address or that address? There's workarounds for that, but they're more of a headache. If you don't have it set to a common address, so you set to something like 192.168.55.1 with a subnet mask of 24, that's a less common one, so you're less likely to have to deal with any of those workarounds. So we'll leave it at 55. Admin password. We're going to go real complicated here because I've got to type this a few times, so There's my admin password, and we're going to click reload. Now, while I'm clicking reload, it's going to reset and configure it. But my computer was assigned a 192.168.1 address. So simple solution here. I'm just going to unplug the edge switch here. That's going to drop the connection here, and the edge switch, because it's managed, doesn't need an IP address. I want the IP address of the edge switch to be in the same 55 range. So when I reset it, it's going to, because it only takes a few minutes from that reload, depending on the speed of your computer, where it reconfigures the interfaces. It reconfigures the DHCP server. So now it's going to be in that 55 range. So this is going to get a 55 dot something address, and this will get a 55 dot something address. So I'll see what address I get. All right, my computer now has 192.168.55.11 as its IP address. So we'll go ahead and ping something. Okay, I can ping. Well, that didn't respond. Let's find something that responds to a ping. Resolved. There we go. Google resolves and responds to pings. So I'm online. I have an IP address assigned to my computer. We can log into our pfSense here. So we're going to click finish. And because I unplugged and plugged it back in, when I click finish, it should redirect me. And if it doesn't, it's going to be impatient. So we'll just do here. Oh, there we go. Now we 55.1. Accept risk and continue. Admin and my rather short password because I have to type it a lot. And we have pfSense loaded and configured. So first things to do here is really up to you. So from the security standpoint, this is the question that comes up all the time is, all right, I loaded it, now what? Is it secure? What are those extra things I need to do? What are the defaults I need to change to make this box more secure? And the good news is, as long as you have a good password, the defaults on pfSense are quite secure. It does not open any ports to the internet. It does normally block the WAN, except for we uncheck those boxes. So the out-of-the-box config for pfSense is quite secure. If there was a more secure default, and this is my quote I've heard them say more than once on the pfSense, if you watch their Hangouts, I think I've heard them say if there was a more secure default way to set it up, we would just make that the default way to set it up. So the good news is you're secure. You don't have any ports open out of the box. Now, it doesn't mean there's not a million things you can do with pfSense to change it, modify it, and bend it to your will. This is one of the things I really love about pfSense is it's extremely flexible. So we're going to go ahead and close this. I mean, this is just letting you know, Netgate, pfSense, community support resources, some support links, etc. And we'll close that because we don't really need that information on here. So we'll start with that, customizing the dashboard. I like to have the interfaces on the list here. What else do we like? We can put the gateway up here. We like to have those on the list. We can list our packages, I guess, so we can customize that. Service status is good too, so we'll throw the service status on here. If you're running OpenVPN, I do like the OpenVPN being on there. And where was the package one again? Installed packages, and I'm gonna say the finest one, the last one it will load on here would probably be maybe the smart status. So you got service status, gateways, captive portal, if you're using that, CARP if you're using that, load balancer, picture. Picture's kind of neat, you can put a picture on there. I've seen a few people do that. It's kind of nice, you can load a picture of, for example, what the network looks like when you're dealing with remote systems so you have an idea. And we'll put the smart one over here. It'll also do thermal status as well if you have those sensors in there. Now, the smart status is only going to be if the system has the ability to see the smart status on that particular one. We're using a drive that does, so that works on there. Now, that's pretty good for the dashboard. It gives you plenty of information on here. You can see that this is an Intel Atom C2758 at 2.4 gigahertz. There's general statistics on here. One thing to note is make sure that you have plenty of room on here. So don't have too much space taken up on here. So if you do run out of space on there, that can be a problem. This is one of the reasons I have that video on building a custom one with a lot of space. But for the most part, not too much going on there in terms of space. When you first started out, it comes down to if you start playing with and customizing the logs. Now, under the general setup, we have the DNS settings. We have the, if we want to change that setting I already set to allow it to, or not to allow it, override. Yeah, that's something that is important, whether or not you want to change the DNS on there. Time zone we've already set, so all these things are, like I said, already configured. You can customize the top navigation. We can switch this to a different color interface, I believe. right here, the login page, you can change if you want. They have different colors for like the login page color, things like that. You could disable dragging of it. There's not a lot I really change much in here. Show host name and banner. There's a lot of little tweaking you can do. I don't do much in terms of that level of tweaking on there. But I do like, because screens are so much wider now, to change that particular one, dashboard column. So we'll go ahead and hit save, and then jump back over to the dashboard here. And now we have 3 columns. Now, if you note when I'm dragging things around here, they're pretty easy to drag. Just go ahead and hit save, though, when you're done, to save the positions that they're in. So if you want to move these around and rearrange it, but as you get more information on there, building your dashboard, having a 3-column layout is a lot easier. And of course, most screens are a lot wider now, so it's pretty straightforward to do. System Advanced. Now, this is where I do make some changes. The default config for pfSense is to put one HTTPS open on the LAN side. It is blocked on WAN, so the out-of-the-box config, this cannot be administered remotely. I'm not going to bother opening it up remotely. It's not needed for this particular demo, but I do like to change the port it's on. And the reason for that is if you're starting to run other services or other things you want to forward or open up the WAN in certain ways, having everything at the default port is, I'm not saying security through obscurity is a good thing, but you know, having it on a different port, because most systems, if there's something on your LAN is trying, it may frequently try that local port. Also, if you start running things like HA proxy, you run into the problems of sometimes you're like, hey, it's forwarding to the web interface, not to the HA proxy that I set up on 443 that I wanted. Those are all issues you can run into, so I do recommend changing the TCP port. We're just going to use 10443 out of habit. Like I said, it's not hard to figure out if something was scanning your network and find it. It's more about just not having it on a common port that will cause conflict with other things you may run, especially if you get something more advanced like an HA proxy setup. As far as the rest of this goes, I think everything else in here is pretty straightforward. I don't see any reason to change this, except I do like to turn on SSH. I usually leave password and public key on, and then once I have my key installed, I'll change it to public key only. So that's reasonable to me to set that. Everything else here as far as defaults works perfectly fine. It does have the ability, if you have a serial console, to redirect all the output if you were setting this up somewhere. So we'll mention that that's in there. And password protect the console menu. I've seen people debate about this, whether or not they would enhance security. Yes, it does, in the fact that if someone has physical access, they would have to put a password in to get to the console. But if someone has physical access, it's kind of game over anyways, because if they can get to the machine physically. So it's not something I usually change at default, because, well, I figure if they got physical access and they're logging directly into it, they can also just reboot with a boot disk, grab your XML file, and extract your passwords. So maybe if it's in an environment you don't think is secure, where someone may be walking up to it, you want to put a password on there, but that is definitely an option that you have. Now, when you do this redirect, so we redirected it here, TCP port 10443, you'll see one moment redirecting to, and it's going to make those changes for me and forward me to the updated port. And we just have to remember to put :10443 each time we log in. So it's going to keep the IP address the same, 192.168.55. Accept the risk, continue, but we've now added the 10443. Now, by adding SSH, we also got a notice over here for SSH keygen and SSH startup. What that did was generate the keys for the SSH. It's just a notice that you get when you do turn it on. Nothing to be concerned about. It's just letting you know that it's done and turned on. And SSH is also going to be opened up on the LAN side only, even though we enable it on the firewall. Unless we create an implicit rule to do so, it's not going to open up. Now, I know you see right here, WAN DHCP6, and it says pending. And I'm going to bring that up real quick. One, I just don't know a lot about DHCP6, well, IPv6, I should say, in general. So it's not something I really use. I know there's a lot of people with a lot of questions about it. I just don't really use it, so that I leave alone. So that's not going to be part of this review at all. I just don't have a use case for it that much. For the most part, everything that we run into generally works best over IPv4, so that's all we're going to cover in this particular video. Now, firewall rules. There's no rules on the WAN, like I said. There's no floating rules. there are LAN rules, and this anti-lockout rule, you can disable this if you want to, but generally speaking, the LAN is where you want the anti-lockout rule. And what this does is it prevents you from creating a rule that stops you from logging into the system, so you can't lock yourself out of it. So like its namesake is, it's an anti-lockout rule. Because if you were to create a rule to block port 10443, well, that would be an issue you ran into. Now, one more thing I will change under advanced over here is under firewall and NAT. This is another customization that comes down to how you want to handle things. You can do this on a per rule basis, or you want to do it this way. I usually do it this way, but this can be done in each individual rule. This just basically sets the default. What you're doing is setting up NAT reflection, or sometimes people call it hairpinning. So let's say I open up a port. So I have a port up on my WAN that opens up something to, let's just, for example, use a camera system. And I want that same IP address, which would be my public IP address, to work inside the network and outside the network for convenience. For example, when you're on your phone, that way when you connect to the LAN, you don't have to change where it connects to you. This is basically creating a hairpin. So when NAT reflection is turned on, I just, like I said, I recommend very in the beginning before you start turning these on, just make that the default. It goes out to the WAN address and it loops it back and says, oh, I seen you ask for the WAN address in this port, but we know that's internal, and it hairpins it back to being local. So when you're on the LAN side or any of the internal networks, it brings that back around. So that's something I like to turn on, and also will save you a lot of time of troubleshooting when you're doing some opening of ports and things like that. So we're just going ahead and hit save, and away we go. And of minor note, I did leave it on, but the web GUI redirect, you may want to turn that off once again if you're using it, because it does listen still on port 80 to redirect you. So we'll go ahead and just disable it and say we'll turn that off. And all that's doing is redirecting 80 to 10443. Once again, if you're running something like a proxy or some other things on here, you're like, hey, I told to hit the firewall, it did, and it keeps redirecting me over here. Yeah, that's because you have that turned on. So that completely gets things off, and so you'll just have to manually remember to type in 192.168.55.1:10443 every time you want to log into the admin interface. It won't, do those niceties of just redirecting you. Now, as far as everything else in here, package manager, routing, setup wizard, you can rerun the setup wizard, updates, pretty straightforward to use update, and user manager. Another thing of security on here. Now, for the most part, there's not a lot you need to do with any of these. Each one of these is for a more advanced use case, but user manager is another one that I'm going to say out of the box default getting started. Yeah, you might want to create something other than admin. So if you create another one, and we'll just create a user Tom, and then we create a password for Tom, and then we'll make Tom an admin. We'll say his full name is Thomas, and we can even paste the SSH keys in here, and we can click save, and we can log out, log back in, system, user manager again, edit. User can't log in. Now, it's still a level of security by obscurity, but by disabling the admin account, someone can't just guess through admin passwords if they're on the local network. They first have to know what username you're using. So it's one more layer, and, hey, at least I've disabled the default admin on there and have it set up so I have another admin user as this. So just one more little thing that I usually do, but not really necessary. I kind of leave that up to you. Now let's get to the networking part of this and setting up interfaces. So assignments, we have a lot of interfaces on here because we have the 4-port Intel card, and this has a built-in Intel card. So altogether, it starts at 0, so that ends at 7, giving us 8 interfaces on there. And the IGB 0, 1, 2, 3 are all on that Intel extra add-in card that I have on there. And then we have the other ones if we wanted to add more interfaces. And we can just do those real quick, so hey, why not? Now, adding all these interfaces does not actually activate them at all. We have to do something to activate them. And these are all physical interfaces, not VLANs. So we click on here to the interface like opt1. It's not enabled. So if we wanted to enable it, all right, and we'll call this some other network. And static. Now, This sometimes gets a little bit confusing because people say, hey, how do we set up a second WAN, and how does pfSense determine WAN from LAN? Well, pfSense, based on the old school monowall and go back to the even old school how things used to work, you never really thought about LAN and WAN. Everything was just an interface assignment. That interface, whether or not it had a gateway that it would get out on, determined whether or not it was a destination essentially, or a LAN, where it would then share out the information and become a gateway itself, or it had an upstream gateway, and that upstream gateway makes it a WAN interface. So actually, let's just name this one WAN 2 and talk about what I mean here. So if this were to be a LAN interface, I would stop here and just assign an interface. But when it doesn't, it has an upstream gateway. We can add a gateway. So just for sake of doing the demo here, let's type in, let's say this is going to be a 10.1.1.15. And we're going to add a new gateway for this one, and we'll call it WAN 2. It's not going to be our default gateway. Let's pretend this is our backup interface. Gateway IP address 10.1.1.1, add, and whatever the net mask is given to you by whoever gave you this gateway, and away we go. So hit save, and technically if I was doing this in my lab, I'd make sure these are unchecked as well. Don't reserve the networks. Whoop. I gave it the wrong name. We have to make sure it's called WAN 2, and an interface with this name exists. So we give that the name WAN 2. Save, apply. So now this particular interface is now called WAN 2. It's applying the changes right now. We know it's IGB2, so it's technically the third port over because they start at 0, and that would be my failover one. Now this became a WAN 2 because it has an upstream gateway, so that's how it knows to be on that side of the network. So let's go ahead and create another interface, and we can make that one another LAN interface. So let's look at the interface assignments again. What do we have here? Let's go with the next one over because this one's WAN 2. So we'll take IGB3, and we'll call it another LAN. So we have this one as another LAN. Now the difference here is we're going to go ahead and go static IPv4. And by the way, on the WAN 2, I could have set it to DHCP as well, and that would grab a gateway, grab everything else. And by setting a port to DHCP, you're kind of implying that, yes, I want a gateway, I want all the settings to come from DHCP, which means it's also not going to be a LAN. But this one will. So this one will be another LAN, and we'll give this a different IP range. So 192.168.200.1. That's going to be the IPv4 static IP of this. We'll make it a /24. So this is our another LAN that we're creating. No preference, no duplex, and actually 4 guests. There we go. Another LAN for guests. This will be a dedicated interface for a guest network. Save, apply, and now we have another LAN for guest interface. But now what's the next step? So next step is creating firewall rules. So we go over here, another LAN for guests. All right, pass, another LAN for guests, IPv4. Protocol, this defaults to TCP, which means, for example, lots of these other things, including DNS, which runs over UDP, and ping, ICMP, down in here in the list, right there, these won't work if you set it to TCP only, which is the default. And I've seen a lot of people create these rules on these networks, and they create a rule and they say, hey, it won't work, it won't get, it won't ping things, for example, but it seems to have some things working. Yes, anything TCP works, anything not TCP won't work. So we're going to change this protocol to any. So we have action pass, and what we're doing is create a rule to pass the traffic on this one, another LAN for guest. The description is going to be allow all. Oops. And why do I have allow in all caps? Don't need the caps on. These are just really handy descriptive rules. We don't really need to get into advanced, but any rule comes with really advanced options if you want to play with them. That goes beyond the scope of this particular tutorial. Now, both this one and this one work fine. Matter of fact, let's plug into it and confirm it's working. But before we do that, we need to have an IP address set up on it. So we're going to go to Services, and we need to go to DHCP server. For every interface you create, whether it's a VLAN or a physical interface you're attaching it to, it does create a list here in the DHCP server, so that's great. We do have to define a range though. So we'll say 100 and to 200. Now you can add a whole series of pools. There's way advanced things you can do with DNS. For the most part, you usually just set one long range of pool, maybe some static on there. But now we have essentially this another LAN for guests. Whoop. Oh, there's a space in front. Please note when you copy and paste, sometimes you copy a space, and if you do that, there we go, it'll tell you the IP range is invalid. So we'll go ahead and hit save. All right, so now in terms of interfaces, we've got this and we've got this one here. So we can now go and unplug this, which is my computer, and we're going to plug it into that other port right here. Give my computer a second to get an IP address. Oh, there we go, already has it. So 192.168.200.100. So let's go ahead and log back in. Now, a couple different ways we can log in. So we'll go ahead and here. And we're still logged in at 55.1, but also, just so you know, 200.1:10443 also lets us log in. Now, we call this guest network, and probably you don't want your guests logging in. So let's talk about creating rules now that stop that from happening. So we're going to go over here to our rules, another LAN for guest. Now, there's a few different ways to do this, and the first thing you want to do is recognize that rules are from top down. I have a specific video about getting started with rules where I dive a little more in depth in it, but the rules are a top down on a per interface basis. So the first rule it matches is going to be what it matches on and then doesn't go any further. So we can put a block rule to our 104.443 source any protocol TCP, and we're going to say actually the destination is going to be the firewall itself. You cannot talk to this firewall on 104.443 from that network. That's an important thing that you want to make sure is in there. If not, anyone on guest can try to get to the interface. Now, granted, you have a good password on there, I'm assuming, so it's not the biggest security risk, but it's not the best. The other problem people have is they assume the guest network should have no access to the firewall, so they block everything to the firewall. Well, that's a problem because you have DHCP on the firewall, you have DNS on the firewall, and if those are providing those things, well, now how are you going to get out to the internet? They need to at least talk to the firewall, but they don't need to talk to this specific port. So we'll go ahead and say this is block web interface. All right. So now we have the web interface blocked. And when that rule is applied, all right, it is unable. So 192.168.200.1 104.443 times out. So we're going to plug my computer back in over here to the regular LAN so we can keep administering it and show you how to further lock down that guest network, because even though it can't get to 192.168.200.1:104.43 because we put a block in there, it can get over to our primary LAN. So if it can get there, then it can go into and get to 192.168.55.1:104.43, and we want to make sure we stop that. All right, back on the 55 network, firewall, rules, LAN 2, whoops, I'm sorry, another LAN for guests. So this firewall, block port 104.443, block web interface. Now, let's say we wanted to block things going to LAN, which is our next goal. So we have this allow traffic. There's a couple different ways to do this, and there's not necessarily one way that is absolutely right, and sometimes there's a lot of customization you need to do where you want it to be able to access some networks and not others. So you can create an alias, for example, say alias, and we can say like an IP range, and we'll add, or we'll label this one my private networks. Because maybe you want to separate things in a couple different networks and you want a list of private networks, and that private network is going to be 192.168.55.0/24. Actually, we want to list it as a network. There we go. dot 0, and we'll call this one LAN. And it's maybe we have more than one of these is why you want to do it as an alias. Now the advantage of an alias, if we had created more than one, so maybe there was a 50 network and the same thing, we'll do this, my other LAN, you can then list out all the networks and then have this block in there. So we only have one, so we'll just hit save and show you how an alias works. Apply, firewall rules, another LAN, and we need another block rule. So we can say block, and then we can go here, block all protocols, not just any. Where's the destination? Single host or alias, and my private networks. Save. Apply. So if it tries to go to my private networks right here, and for each time I add another private network, I add it to the list, this is not allowed to have that as a destination. So it's not allowed to have the destination firewall, and it's not allowed to have the destination these networks on here. So now all I have to do is update the alias, and by updating the alias, if I have this rule repeated in different places, it'll work. Another way to do this is go ahead and edit this rule here, and you can just say invert match and go right here and say invert match LAN net, save, and now we can say the destination, as long as the destination exclamation point means not, is not the LAN net, we can go. But I only specified one network, so then I could specify my private networks also as an option as an alias and say destination, not that. So there's a couple different ways you can do it in a single rule, separate rules. Allow traffic to accept is how I would probably relabel this rule. So I would say, like, you know, and we'll actually change it to an alias in case we had more than one. So my private networks, allow traffic to accept for my private networks. Save, apply, and actually we're going to go ahead and delete this rules. We don't need rules to be twice. So block the web interface, allow traffic for except for my private networks. So all right, that's been applied. And hey, why not? Let's go ahead and try this real quick. And we're going to pick something we can ping. So go over here to services, DHCP server. We'll go here and we can see what things we have. So here's my laptop at 55.11 and we have 55.10, which is the, I think this is probably, let's go over here. Cool, we can see it. This is the edge router I'm able to ping right now. So from the 55 network, I can easily ping this, and I shouldn't be able to ping it from that 200 network. So we're just going to move my computer back over real quick. Okay, it's on the 200 network now. Let's ping Google again. Google's responding. Awesome. So I'm online, but what about when I try to ping 55.10? Nope. I have now blocked the LAN network from this particular network interface. So my guests can get online, but they can't see what's on my LAN or whatever you put on there. Maybe you have your camera system on that separate one, and now you've stopped anything from coming over there. So now I'm going to go ahead and switch it back and put it back in the normal network, and we'll kind of walk through this same scenario, but we're going to do it with a VLAN this time. So the concept's almost identical. The firewall rules, DHCP servers can be the same, but there's a little bit of difference in how we assign the interfaces, and I want to make sure that's clear because, well, VLANs are extremely convenient, especially when you have larger networks and you don't have the luxury of running one individual cable to each segment of the network to each individual switch. And VLANs obviously create a lot of easy ways to segment things. So even though they share the bandwidth, there's still a lot of good reasons to use a VLAN to create separate networks. And it makes it easy, especially when you just need to pivot back and forth between them. All right, so creating a VLAN, interface, assignments. Now we have to know which interface we're attaching this VLAN to. And we're going to be connecting it to the LAN, which means that's the shared physical interface that the VLAN will be on. And we're going to go over here, and we'll define a VLAN. VLAN tag 69, the 69 network. And right here, we assign it And don't worry about the priority. It's up to you. It's advanced and goes out of scope of this. If you are using traffic shaping, you can set priorities, and that can be at the switch level where it prioritizes certain traffic over other traffic. Now, this is a problem you're going to have, and if you say, hey, I've been trying this and it's not working, I'm running this virtually, you handle if you virtualized pfSense. If you load it into some other hypervisor, on a per hypervisor basis, you may handle VLANs differently because, well, it's not that there's issues with it, but it is one of the nuances of having that level of support on the drivers for the hypervisor. This is one of the challenges when you have it virtualized. When you're running on physical hardware, though, pretty straightforward and easy. You just assign this. The exceptions are if you're running a Netgate 7100 or Netgate 1100, look up the videos I have on those. There's a couple extra steps to tag the VLANs in there. Not an issue on the other devices or in this self-built situation with this Intel card. The VLANs just work by assigning them to an interface. So we have IGB1, VLAN tag 69, and we call it the 69 network. Now, when we go to interface assignments, here's that other assignment. So we're going to go ahead and assign it. And then, like I said, it works just like a normal interface. We'll give it a name. VLAN 69, static, 69.1, make it a /24. Now this is up to you. You could make it bigger than the /24, but that's pretty much, way to do it there if you want. If you wanted to be a /22 or a bigger range, whichever's up to you. And I typed in 61, so let me get that typo fixed. Save, apply. Firewall rules. There's no rules by default. So we'll go here and say any. Now here comes the next question. Is this another secure network? Do we want to do an invert match and say that same thing, single hoster network of my private networks? Or is 69 your private network and you want to keep that in your private network list? So instead, we're going to say any. We'll make that assumption on this particular network. But we could have done either way on this. So we won't say invert match because that would make a mess. We'll just say allow all. Hit apply. And now this network's in there, but this network's not set to private, which means the guest can get to it. So we don't want the guest 69ing, so we're going to go over here and say firewall aliases. We'll edit this alias. And we'll add network. It's a .0 on this part here, /24. Save, apply, and now when we go back over to the rules, the guest networks, now I have both applied to them. Now this is one of the reasons it's nice to use an alias, so when you know you're building out private networks and then you've built out different guest or security networks and you don't want them to have access to something, easy enough that when you have the alias, it applies everywhere universally. So I'd make one change to the alias and universally it goes everywhere else. And also, if you wanted to take this network, now we allow this over here, and we have this right here. If we wanted to say, but we don't want the 69 network to be able to get to the web interface, you'd have to actually do a couple blocks, because one, it could still get to the 55 interface and get to it, but for terms of duplicating it, that's what the copy's for, and we can just copy it to another network like this and hit apply, and now that rule will copy over to the other side. So you do have to redo the block rule for each network you don't want to have access. Now, what we didn't do yet, though, was set up a DHCP server. Once again, don't forget that part. Range, we'll say 100. Make sure you don't have a space in it this time. 100 to 200. Save. And now that is ready to go, and now I can plug anything I want into that one there. But obviously, I need to define this in my switch. Now, I'm not going to spend a lot of time on this, but the Edge Switch 10X, let's talk about how it's plugged in real quick. We have this port coming from the LAN and goes into port 1 on the Edge Switch 10X. And then we have port 2 right now plugged in and going to my laptop. And this is going to vary a lot based on the interface for whatever managed switch you're using when you're defining VLANs. One of the reasons we like the Unify platform so much as the Unify one specifically. That line has got some of the easiest VLAN setups. I have videos on that particular topic. So really easy to define VLANs inside of that. When you're defining them in other switches, this is where people get stuck because they have similar but not always the same methodologies to do this, and it varies from Cisco, it varies from MikroTik, it varies from Edge. The concept's the same, the protocol is standard, but the web interface is up to the UI designers. So I'm going to show you, and I have a review on the Edge switch, but this is the Edge switch to set up a new VLAN ID tagged 69 right here. So we have this set to be the trunk port, port 1. Then we have this to allow all untagged traffic to come in. Then we say grab the tagged traffic on here and forward it over to here as untagged. So, and then we want port 5 excluded. That way, when port 5, it doesn't ever give me the LAN, it only gives me the VLAN 69 traffic, so it's excluded from the default tag of VLAN 1. So natively, VLAN 1 means untagged, or basically all the traffic comes on VLAN 1 by default on pretty much everything, including the way pfSense put things out, and then we peel out the one particular VLAN. So I have a separate review of this, if you can find on my channel, where I talk a little bit more in depth about that, but for this particular switch, that's how we define it, and that's how we define port 5. So let's see if we have this VLAN 69 working, and if I did it correctly, I should be able to take and move this network cable from here over to port 5. And now I should get that other address, and it should work tagged with the VLANs. Let's see which IP address my computer gets. All right, 192.168.69.100. Let's go ahead and ping something like Google. And hey, look, we're online, it's up and running and working. And because we didn't block anything, I can still get to the web interface on that particular one, or I could, copy the block rules and make this a private network. So now you get the idea of how to set those up. So this should give you a good concept on how to get all of those things up and running. So let's talk about the plugins or packages that come with pfSense. Now these are directly pulled from the pfSense repository. They're official and vetted by pfSense, by the Netgate team. And I already shut this down. I didn't want to do it on this because I don't feel like setting all the plugins up. I was going to go over to our production machine and show you what we have installed. Now these are not the same plugins we install for every client, but there are clients that we use that have all of these needs. We decide which packages are installed based on the use case and based on what the needs are. So I'm going to walk through, because our system pretty much has all the ones we use commonly when there's large projects all set up here. So I have separate videos that will break down in detail any one of these and the configuration guides for them, and I'll be leaving that in a playlist down below. So we'll start at the top here. The Automated Certificate Management Environment for automated use of Let's Encrypt certificates is wonderful, combined with, and I'll just put them together, HA Proxy, which you'll see down in here. Those two work wonderful together. I've got two separate videos on that, one for using wildcards, one for just setting up, configuring it. But if you want an automated way to handle certificates and to have reverse proxies and everything else, that is just a great plugin for that. And that's not something every client needs, so it's not like we automatically load that. It's just kind of on a as-needed basis. ArpWatch, once again, not something a general small office would use, but if you have, for example, a separate network where you have certain servers and you want to keep an eye if anything pops up on that network that wasn't supposed to be there, ArpWatch is that tool to do that. It looks at the network, and if a new MAC address shows up on that network and it shows up in the ARP table, because, hey, look what I found, and this was unexpected because there was a change. It'll also let you know if someone tried to spoof a MAC address, because same thing. If something changes and the ARP table changes on a particular segment of the network, it lets you know. Don't do this on your main LAN if you have things coming and going, or you'll just get bombed with notices and it becomes, well, ineffective at that point. But on a network that essentially is not very dynamic and things are statically set, and you have this group of servers that run in there, well, ArpWatch is great for watching that. The AWS Wizard is something that comes default with the pfSense installs when you buy the Netgate hardware. I'm not something I really use. DarkStat, I've never done a full video on it, but DarkStat's definitely pretty cool for just getting some general statistics on things. FreeRadius 3. now once again comes down to use case. Where do you want your Radius server to live for authentication? So if you're going to use Radius for authentication, you can use this in Windows, you can then tie it to Active Directory, or you can run a standalone free Radius server right on your pfSense. Why would you do that? Well, I have a video talking about how to use free Radius for authentication on your network, and specifically with OpenVPN. So those two things work together really well, and so if the client doesn't need just standard OpenVPN install, or is going to use the pfSense for all the authentication, or is going to use the pfSense for authentication and need something more advanced like free Radius, that's there. When they don't use free Radius, because it's not necessary for OpenVPN, you use the standard user manager. You can create users that don't have admin privileges, that really don't have any privileges. You're just using them to authenticate. So don't use the admin user for pfSense as your user. Create like another user, like, hey, your username _VPN or whatever nomenclature or whatever methodology, I should say, you want to use for naming that. Whatever methodology works for you, that works, but free Radius is a completely separate database that can be maintained, and then you can point OpenVPN at it, and I have a separate video on that process. IFTop, I don't use this very often. It's kind of a novel thing that you can use on the command line to do command line showing bandwidth per IP address. I think I may or may not have done a video on it at some point, but it's just novel to have installed there. Same with iPerf. iPerf is benchmarking, and you can have this and it comes up on a web interface, so you can do speed testing. Now that's not doing speed testing through the firewall, it's speed testing from port to port, and that's still sometimes pretty handy to do, so hey, why not? It doesn't really take up much space, it's easy to load. IPsec Profile Wizard, this is something else Netgate installs. It's not something I really use, I just didn't remove it. Same thing with the Netgate Core Boot upgrade. This is for updating Core Boot on Netgate devices, and something else that if you have a Netgate device, it's going to come loaded by default. Nmap. I like that Nmap is in here because, well, I can pivot into a network and get something set up and run Nmap, or having Nmap right on the pfSense system is handy because then I can take and scan a specific segment of network with some Nmap, go through, find or discover things with their pfSense, and pfSense of course usually sits at the intersection of all the different networks, so being on one box, so it's actually the pfSense box, you're at the head end and then pivot through everything to create Nmap scans. So having that built in, yeah, that's easy. OpenVPN client export, hands down one of the, if they're running a VPN, you always run this. When you look at my OpenVPN videos, you understand this packages the executable with the certificates and the settings in it for OpenVPN. So when you set up OpenVPN, you want a one single executable install with everything rolled into it. That is the tool that does that for you. So if you've watched my videos, and I've had a few people skip over that part, they're like, hey, I can't find that export, it's not built in. I almost think this should be a built-in one, because if you're going to do anything with OpenVPN, use this and makes your life a lot easier. If not, you have to manually set up everything, which was tedious when you want to manually create an export file, but this creates it all for you. So that's one of my favorite features because of the way it does the packaging for OpenVPN. PF Blocker Devil. Devil is important, which means development version. I've done videos on PF Blocker NG. This one's great. I definitely like that quite a bit as far as being able to manage things for blocking and DNS. Like I said, I got a couple of videos on that. Watch the most recent one because the most recent one covers the Devil version versus the non-development version. Status traffic totals. It gives you some traffic totals page on the status menu. Give a total amount of traffic passed in and out over the period of time, hours, days, and months. Uses the VM stat for collection. And Suricata. I just did a video on Suricata. And Suricata is extensive, great for security, also very extensive to set up and tune. That being said, it's still not something we load for every client because it provides very limited protection if you're not opening any ports. It mostly provides lots of false positives on general generic networks and does require a bit of tuning, so it's not like an automatic because it's it's an upsell, so to speak, to have us set up and tune that as opposed to, and it needs constant tuning. So it's not for everyone. That would be the best way to describe Suricata, and it kind of depends on the use case on there. Especially home users who want to use it generally find themselves, if they have no ports open, just with a ton of false positives as well. But watch my video on Suricata to talk about some of the details on that. The Zabbix agent. Well, that's only if we're going to monitor it in Zabbix, and if we're going to actively watch what this pfSense does, watch for uptime. Zabbix is a great way to do this. There is a Nagios plugin as well if you're a Nagios fan. I don't use Nagios. I don't have an interest in it. People ask me to review it. I like Zabbix, the competing product to Nagios, and one of those ain't broke, don't fix it, don't have the time to learn it, but it does support both for monitoring on there. Now, in terms of the entire list of every available package, that's all listed right here. There's plenty of them in the list. If you have some other specific thing you want to do, and I know someone's going to ask about Squid and SquidGuard. I have a video on that of why I don't like Squid. It just becomes a headache trying to install certificates on there, so don't expect me to run a video or create a video on that topic other than my rant about Squid. Not a big fan of it. This is also interesting, and I don't use this, but I know there's some use cases people have, is the Telegraph plugin. It is an agent written in Go for collecting, processing, aggregating, and writing metrics, package dependencies, etc. I've seen a few people talk about this. It's not something I actively do right now. Exporting things with Telegraph over to another server for, getting data pushed over if you want to do some external analytics on there. So that's kind of neat that they have it. It's not something, maybe at some future point I'll take a look at it. And if you want the UPS system, for example, to shut down the pfSense when there's a power outage, that is built in as well. So you can, for controlling all APC UPS models, and I think there's that one. I believe there's one more plugin that does the same thing called Network UPS Tool, or NUT, and it provides monitoring for unauthorized power supplies and shuts them down. So that kind of covers it for the plugins. But now, where do the plugins show up? Well, that's a little bit more complicated because the answer is really everywhere. So if you install a plugin that shows up as a service, like Acme certificates or HA proxy or free radius, yeah, those are all places those will show up, or the Zabbix agent there. In the case of traffic totals, and we can go over here to traffic totals, that shows up right here. So when you're breaking down some of the graphs and things like that, which, by the way, it is normal for this to pause before it loads any of the information in there. That is something that definitely happens when you're doing the traffic graphs. So, all right, and it does, as I said, it takes a second to load, and here's why. When it renders the page, whatever they're using, how they render it, it's a lot of data on there. So when you look at the memory footprint of this particular page, you can see it's one of the biggest ones here in my task manager here inside of Google Chrome. So it does take a little while to render this and get all the data, but it does break down these kind of cool looking graphs of, data, what we're using on each one. It's kind of nice. I like this plugin or package. Works pretty well. Now from here, I want to go through all the menus. So I've covered, getting set up, the packages we use, kind of all the other process. Now I just kind of want to do a general overview of all the features. So I just want to make sure this next part is kind of like just that I'm going to talk through everything, but not dive into detail on any of them, just because of brevity and, well, how far we are in this video so far. And I don't use all these features, but at least I'll show you that they exist, kind of give you a broad sweeping of all the different things in pfSense. Even though I don't use them, these are kind of neat to have. And one of the first things I'm going to talk about was going to be BGP. Now I bring this up because this is a real enterprise level feature. There are people who frequently have set these up in data centers at that edge level and have large blocks of IP address they're going to handle with BGP. So there are a couple different tools in terms of ways you can do this. This goes well beyond the scope of the video because I am not a BGP expert. It's not something I do very often. Frequently, I go through the basics, and usually if I'm talking to a data center, we'll basically load the plugin, get it set up, follow the data center people of, hey, here's the announcements, here's the route announced that you need to match in here, and go through it. I've been thinking about setting up something in the lab to really demonstrate how that works. It's a little bit complicated because BGP itself is not a simple task, but it's also not something even most business users run into. It's more goes into if people have large blocks of IPs. But I do want to bring up the fact that yes, pfSense can handle it, and Netgate has an entire BGP video in terms of talking about it and walking you through step by step the BGP features on there. Now going back over to I mean, you could look at the system here. Like I said, core boot upgrade. There's not much to cover in this, but we'll walk through some of the other menus and things that are on here. And once again, things not often used, but are available in here is things like the interface groups. So if you need to create a group of interfaces to apply rules or features to, that's an ability. Wireless. I have a dedicated video for this, but once again, something I rarely use. I did the video for fun. It'd be cool if there's some future that they have some better wireless cards that are supported in there, but for the most part, when you're doing, especially business Wi-Fi, there's better solutions than popping a card in a single router. Anyways, usually you need something larger, more scalable. We covered VLANs, but we didn't cover QINQ. Those are Q and Qs, and it's specific IEEE 802.180 standard. So it is networking standard informally known as Q&Q as an amendment to the IEEE. It was incorporated on the base of that. So this technique is also provider bridging or stacked VLANs. So if you have one of those unusual, unique use cases where you need to use stacked VLANs, for example, that's actually something supported in here. It's not something I've used or have a video on. PPPs or point-to-point protocol interface types. For 3G, 4G modems, that is something built in as well. It's not something I've done a video on either. They got some documentation here. It's not something we use very often. Generally speaking, if we're going to have a failover device that's 4G, it usually provides its own IP address. So we just plug it into the secondary WAN port and set it up as a failover. So that's, I have a video on doing failover, so it depends on how the device is. But yeah, it does have support for certain devices on there. Setting up GRE interfaces. Once again, a feature I don't use very often. It's an edge use case, but that's built in there as well. And if you're not familiar with GRE, it's a generic routing encapsulation, and then the other one next to it, a generic tunnel interface. Those are both supported in here, so it's very similar to GRE. Both protocols are means to tunnel traffic between hosts without encryption. So GRE, it works at the layer so it can encapsulate all the traffic going across, and that's something you can, do on pfSense. Well, like I said, this is one of the amazing things is they've got so much built in over time that has been, put into pfSense that any type of weird use case, there's usually a pfSense solution that it can handle that type of thing. Bridging. I've done a video on setting up bridges. Now, bridges are particularly cool because when you take a bridge and set this up, and I've done a video on how to do a transparent bridge with Suricata for filtering, which is really neat. It basically creates a very customizable switch that you can do all kinds of fun stuff with and really fine tune it. So it's neat that it does this. You can set priorities and it sees all the networks. You can set RTUSP or STP, dive through all the protocols, set the private ports, set port mirroring. It's a really neat way to bridge interfaces together for special use cases, or in the demo video I do have on this, setting up transparent bridging so you can essentially passively watch traffic with something like Suricata and apply rules to it. Now, I covered NAT rule and aliases, but there are virtual IPs and traffic shaper. Those are going to be used for a couple things. So virtual IPs, really briefly, I've covered those when I've done the HA videos. So this does have full HA ability, and I have videos on how to set up high availability on here, and you're going to build virtual IPs. Virtual IPs are also used for assigning a block of IPs to a WAN address, for example. So you'll have your primary IP, set up the gateway, and then you can attach virtual IPs. You can do it on the LAN side, you can do it on the WAN side. There's a couple different options when you do these, whether they're a virtual IP for HA, a virtual IP shared between more than one device, or just assigning multiple blocks of IPs to a single interface, whether it be LAN or WAN. Those are all options you can do in virtual IPs. And then Traffic Shaper, which I have pulled up here. Now, the Traffic Shaper, I've never done a deep dive into. There's a video by Mark, and it's called The Comprehensive Guide to pfSense Traffic Shaper. The visuals in here, I think, are really, really relevant. Even though it's on an older version of pfSense, what really will stick out if you watch this video is you'll gain a better understanding, because he does a great job of explaining how traffic shaping works. And that's what I think is a key takeaway from this video. Matter of fact, I think the video is more about traffic shaping in terms of, and it doesn't matter about pfSense, just in general, the first half of this hour-long video breaks down all the details on traffic shaping. Matter of fact, more than half of it is. So this is a great way to learn traffic shaping before it even gets to pfSense. For the most part in pfSense, the wizard works fine, and that is still the video because I don't think I can do one better. That's the video I frequently refer people to when they say, I want to understand traffic shaping better. I'm like, Mark, I don't know if he produces videos anymore, but this particular one was really good, and I'll leave a link to it below. But it's obviously it's on YouTube. It's called Comprehensive Guide to pfSense 2.3 Part 9 Traffic Shaper, and all the animations and everything are great to explain it. So that first will give you a good understanding of, one, the complexities of traffic shaping, two, why you should probably just run the wizards, and the wizards work really good. The other thing I do have a video on is how to set up coddle queue limiters, and I've got a specific video on this. So does the Netgate has a Hangouts video where they talk about it more in depth. That can be a good way to tune it. It can be a little tricky to tune them. That's one of the reasons they have the wizards in pfSense to run and do this, because traffic shaping is a complex topic, and I think Mark did a great job on that. So I'll leave that there. Now, one last thing in a firewall is scheduling. If you have a use case for this, I don't, but I've had people say, hey, I do this so my kids go to bed at night. I have the firewall set to block their computers. I have rules that are tied to a specific schedule. That's a really cool thing. I really do like that a lot, the fact that there's a scheduler in there. It's just not something I use very often, but it's novel. As you can see, I'm not really going through and using it, but hey, it's pretty cool if you have that kind of use case. Now, going down the list here, I've had a few people ask me to do a more detailed video on like a DHCP server. There's really, to me, it seems self-explanatory on DHCP. You set it up just like I showed earlier in the video. But I do like when you go to the log settings in there that you can just click the plus and add a static mapping. But of note, and I'm not going to go any further than this on it, but I will mention that with that setup, you do want to make sure that you don't try to map things in the middle of the pools. That is kind of an annoyance that you can't statically map something. So if the pool goes from 100 to 200, for example, you can't map something statically at 150. You can map it from 99 below or above that 200, so 201 on up in an IP range. I bring that up because there is kind of a workaround for it. The DHCP server does support multiple pools, and we've had to do this because we had someone who had, when we did a rip and replace to their firewall and we put a pfSense in, they had static mappings in the middle of the pool. The workaround is you can create multiple DHCP pools. It's actually really easy to do in a DHCP server. The simple way to do it, but annoying, is the fact that I can add a pool from 100 to 149, then start another pool that goes from 51 to 200, and then I can statically map the 150 in between. Kind of annoying you can't map in the middle of a pool, but actually I've seen some firewalls that can, some firewalls that can't. So it's probably better that you don't have things scattered all over the place. Generally, you want to put all your servers in one block or grouping and maybe all your other devices in another. And I like to have some level of organization for it. But when we take over networks, it's not always as easy as that of just swapping everything to it. Makes us happy. Sometimes we have to deal with what we have because it would be greatly disruptive to do it otherwise. Now, VPN support, I've got separate videos. I've not done a video specifically on IPsec VPNs or L2P in there. Most of the time, you're wanting users to connect. If you want users to connect, OpenVPN is your go-to. It works, it's well vetted, it's solid. That installer allows you to export a single executable, run it on a Windows computer. It works fine in Linux as well. Not the installer, but the export file it creates can be imported. I've done a video on that of how to import it into like an Ubuntu-based distribution. OpenVPN is a great go-to for individual computers connecting. When you go site to site, IPsec going to be a little faster and works really well. So no problem running the IPsec on there. And we have had clients who have things like IPsec tied into different cloud services. We've actually had, it's more troubleshooting. We've done IPsec tied to other non-pfSense firewalls as part of a requirement for setting up users, which includes several healthcare clients we have require IPsec VPNs. Matter of fact, one large healthcare provider now has documentation on pfSense that we helped make to how to set up pfSense to connect to their healthcare system. It was really easy to set up. And one thing about pfSense, and we're going to not go in depth on this, but something worth mentioning is the logging on it is wonderful. Matter of fact, it's frequently I find when we're troubleshooting, the pfSense is where I'll go to logs. One of the ones we had to set up between another firewall, the logs they're bad. They just did not have enough detail to ever tell me why things weren't connecting. But by looking through the pfSense logs, because they're so extensive, I was able to figure that out. So that's something that I found really helpful, that there is a lot of extensive logging in pfSense. But it does have all those VPNs and different types you want on there. Captive Portal. Now this is also under the services if you want to set up Captive Portal. I might do a video on it at some point in time. And once again, this is something you can tie in with Free Radius as well. So Captive Portal, Free Radius, and assign like bandwidth and things like that. It's on my to-do list to do a video on it. I just loathe Captive Portal. It's only if I absolutely need it. Any restaurant that thinks Captive Portal is the way to get more customers, no, it's a way to get people to get aggravated because they are using an iPhone, it doesn't like your Captive Portal, and it just skips it. And because people generally have good internet on their phones here in 2020, unless they're in an area that doesn't have good internet, they won't bother logging in and agreeing to whatever your terms and conditions are. That's well proven. We even had some commercial restaurants that are franchises that hate the fact that the corporate makes them put a thing in there because it's the #1 complaint that, oh God, they hate the stupid splash page they have to get to with the Captive Portal, and it makes people come and talk to my staff member. And this is at a fast food restaurant. They actually contacted us, the franchise owner, and we put Wi-Fi in there, which I know is against the franchise rules, I'm imagining, but they're like, yeah, people just want Wi-Fi, and we like having a Wi-Fi that doesn't make them come up and ask questions to the people all the time that are serving their burgers. So Captive Portal, love-hate relationship. If it's a necessary evil, it does exist inside of pfSense, and it works as well as Captive Portal works. It's not the fault of pfSense or any other Captive Portal. They always have problems with phones. That's your big hang-up. Captive Portal works pretty good when it comes to browsers. Even Windows 10 has gone much better with Captive Portal and understands to redirect it. And my Android Pixel phone works good. Samsung, I don't know what they're thinking. They don't seem to like Captive Portal. And iOS that's a random crapshoot of. I'm not an iOS user. I know they have a lot of trouble with. At least my experience has always been they seem to be the more troubled people when trying to get onto Captive Portal and get signed in. But I'm not going to spend too much time dwelling on it. It does exist. Maybe one day I'll do a video on it. Let's move over here to status. These are all the statuses for all the different things going on. Now, these statuses you can get to, and I'm going to mouse over right here, related status page. That's commonality across pfSense that you'll see. So the top of most services also have a related status page where you can see all the leases and things like that. Or you can go here to the general status page and you can see things like, let's look at the queue status. You can see what's in the queue, what's going across. This is for the traffic shaper. And there's a lot of different things in there. System logs, the traffic graph that I showed earlier, your gateway status, HA proxy stats, interface stats, load balancer, monitoring, etc. Now on to diagnostics. Diagnostics are wonderful in pfSense because of the one I use the most, which is going to be your pftop. I've got some videos where I talk about troubleshooting pfSense. I go right to pftop to be able to figure things out all the time. It is really helpful in watching and tracing any connections, and of course it's got filtering, so you can filter for a very specific connection. Even on a very large network, you can narrow things down right away to exactly what you're looking for. So I probably use that more than anything else in here, but there are things like backup restore, command prompt, darkstat. I mentioned before, darkstat gives you some stats. DNS lookup, this is kind of neat if you're having a weird DNS problem. You go here to DNS lookup and you can look at this. Now, this is particularly handy if you have a different result than your client and you're remoted into your client. You can remotely go in, do DNS lookup on their system. Okay, what does their system say? And kind of start pivoting around and looking around in there. So that's definitely something that's pretty helpful on there. Now, oddly, if you're wondering how to reboot or shut down a pfSense, those are located here. I always thought they should be under system. There's so many other things in here. It would be shorter if they were under system, but I don't get to make that choice. Perhaps someone has a hack that moves it over there, which would be kind of funny. And it's not that I reboot it or halt it very often. I just always thought those were misplaced. But the designers think otherwise. I'll disagree with them on that. But hey, packet capture. Now, I have videos on how to do full packet capture directly into Wireshark using pfSense and SSH and tunneling all the data over. But it also just has the ability to create a PCAP file. So if you want to filter down, which is obviously a better idea than just dumping everything, but you can go in here, grab a packet capture, download the packet capture, even on a remote system. And a good example of this is going to be when you're troubleshooting a VoIP phone. You're going to go, all right, I know the IP address of the phone. I don't know why it's not working. Give me all the data from that phone and filter it to the host even the port if you need to, and grab all the data related to it, drop it into a PCAP file, throw it over in Wireshark, and do the diagnostics. Great that that's just a default feature built into pfSense. More advanced, like I said, if you look in Wireshark and pfSense, I have ways you can filter data right out of pfSense right into Wireshark, which is great. So that's about it for the diagnostic. There's ping and ARP and authentication testing. There's a lot of little things you can do in here that are just general handy utilities. And by the way, when you do authentication testing, each authentication server you set up, whether it's the RAD server or Radius server, I called RAD server, or local database, or any other ones you've added, especially if you've tied in some external authentication. This is nice. That way, if the user can't log in, you're like, oh, that's weird. You can try their username and password here and test it against one of those authentication servers you set up. These are all those little tools that just make your life easier when you're going through and troubleshooting, is spend some time going through the diagnostics. But like I said, when it comes to tracing, there's a lot of that. Oh, there is a port test on there for if ports are open as well. I've suggested people use that quite a bit, which is down here, test port, host name to lookup, and this can be internally or externally. Because before you port map something and someone will go through NAT and say, hey, I want this opened up and it's not working on my WAN side, I can't seem to get there, I'm using some external service, I'll jump inside pfSense and look internally, and if I find the device isn't responding internally, well, it's not going to respond externally. So once again, another great troubleshooting on there. Now, system logs. Like I said, pfSense does a good job on this. They dump all the system logs out with a lot of detail. That is handy when you're trying to troubleshoot, especially VPN. There's going to be a lot of detail in the VPN. There's going to be a lot of detail in the firewall logs. Make sure, if you choose to keep a lot of logs, and this is a tunable setting, that you also have enough space for them. And the other thing you can do in pfSense, push it to a syslog server. And currently this is being pushed all to Security Onion for all the syslogs. So that is a great way you can do it. You can send everything to a remote syslog server or multiple syslog servers if you have more than one place you want to land it. This is a way to handle, without having a massive drive, a place to land all the logs. So that is definitely a feature in there. I will comment though, I think logs should be in reverse order. They default to the newest logs at the bottom. To me, I always want the newest logs at the top so I don't have to scroll down. And the GUI log entries defaults to 100. I set it to 200. You can set it to higher so you can dump the logs on down the list. If it's more helpful to you, you can set it a little higher. Depends on how fast your machine is and how, not your pfSense machine, but your browser for handling how much gets dumped on the screen at a time. So that's kind of a personal preference on there, but in terms of show logs at top, I do wish that was the default, but it's easy enough to change. You just do that. You can also reset all the logs files and clear them and wipe them all out if you feel the need to do so. You can disable writing to local disk. I don't recommend it because you usually want some logs on there because logs are your best friend when it comes to troubleshooting, but those are some tuning options in there. And because it would reveal lots of details of names and everything, I'm not going to show you all the logs for OpenVPN system and everything else, but everything does have logs that it dumps on there. Now, the last little advanced thing I'll talk about in pfSense that kind of goes everywhere that you look. So let's pull back up like the DHCP server. Sorry, I mean DNS server. So we're at services, DNS, use all of our general settings. We'll scroll down a little bit to custom options. Now, this is something that is persistent throughout pfSense. There's easy ways without going to the command line, without opening up special config files and adding something on, and this is something that survives upgrades, reboots, etc., and is part of the actual config XML file, is custom options. And I bring that up because for any particular service, they have created a lot of menus, but maybe they didn't create that one extra thing you want it to do, that one extra parameter that you want to pass on the command line. And that on many other systems is either impossible to do on some firewalls or would actually require you to go through and edit some special config file that probably wouldn't survive the next update. pfSense thought of that, and they have this option for custom options. And this, like I said, through many of the services have this at the very bottom. You can just pass whatever parameters you want to add on in the config file without having to go to a command line and edit the config file. So I like this feature quite a bit, and it's once again saved as part of your XML, so it survives updates, upgrades, and is part of the backup. So if you have those weird custom things that somehow they didn't make a menu for, which they've made a menu for most everything, you can then pass those through. Now, in the case of exactly what is this, This is the way PF Blocker integrates. So PF Blocker creates a list of the DNS blocking information, and it wants it added on. So you're saying server include, so hey, use the config file plus include this config file and passing a parameter along as well. All right, so that's it for getting started with pfSense. And this should hopefully get you started, get you loaded. You're still going to be debating probably which way you want to do this, whether you want to just buy a device or build a device or virtualize it. And like I said, I mentioned in the beginning all the different pros and cons of those. But this is enough to get you going with it. I'm going to make a playlist that I'll leave linked below for any specific topic where I need to go in depth. Because some of the videos where I go in depth on like OpenVPN or how to set that up, I'm going to build that list down below so I have all the most recent versions, because sometimes there's more than one version of those videos. I'll make sure I have the most recent one only in the playlist, because sometimes I leave the old ones in case you're using an older version or have some reason to reference them. They're pretty much still the same, but when I remake a video, I will cover a lot of the nuances and changes that may come with a new version of pfSense, and sometimes I just haven't had time to recreate some of those videos when something changes, but you can kind of get through if the menus have changed a little bit and see that it might be a little different, but it's enough the same that you can get the idea of how it works. So good luck. If you have comments, concerns, head over to the forums. I'll link this over in the forums where I'll actually probably have a list of the videos as well, so we can have a more in-depth discussion of maybe what I need to cover next. But hopefully it's enough to get you started and get you playing with a pretty outstanding when it comes to features firewall. Thanks. And thank you for making it to the end of the video. If you like this video, please give it a thumbs up. If you'd like to see more content from the channel, hit the subscribe button and hit the bell icon if you'd like YouTube to notify you when new videos come out. If you'd like to hire us, head over to lawrencesystems.com, fill out our contact page, and let us know what we can help you with and what projects you'd like us to work together on. If you want to carry on the discussion, head over to forums.lawrencesystems.com, where we can carry on the discussion about this video, other videos, or other tech topics in general. Even suggestions for new videos, they're accepted right there on our forums, which are free. Also, if you'd like to help the channel out in other ways, head over to our affiliate page. We have a lot of great tech offers for you. And once again, thanks for watching, and see you next time.